Alright, hello everybody. Let's talk about some parametric equations. So this is a really fundamental topic in pre-calc and calc and physics. So let's talk about it. I'm not gonna write it out. Too many words. Too many letters. So yeah, let's talk about this. So what's a parametric equation? Well, we know what our normal equations are, right? We say y is equal to, and we put it in a function of x, alright? Usually x is what we call the dummy variable, right? What that means is that we assign x any value. We say that if x equals 0, y equals this. And if x equals 1, x is not defined as anything. X can be anything. Y is dependent on x, and x is independent, so it's a dummy variable. Now, what's a parametric equation? A parametric equation is where we define y and x both in terms of function of t. So instead of this, we'll have y equals g of t, and then x is equal to let's say h of t. Let me rewrite this. Sorry, yeah. So now x is equal to g of t, while y is equal to h of t. So now t is a dummy variable, while x and y are independent, and t is independent, while x and y are dependent on t. So we set t equal to this, and then x and y will be defined by that. So we'll be talking about how to convert from one to the other, and we'll be talking about how to analyze this. Now, let's first talk a bit more about this new idea that we've come up with. First of all, why are we doing this? Well, we know that from the vertical line test that if we have some graph, we can't graph anything. We need to use the vertical line test, which says that if there is at least one vertical line that passes through more than one point on the graph anywhere, then that graph is not a function. So like you might be thinking, then how do we graph the circle? We have x squared plus y squared equals r squared, right? Or x minus h squared plus y minus k squared, or whatever. But let's say we had this. If we solve for y, because we want it in terms of y, we get y equals the positive or negative square root of r squared minus x squared. This positive or negative, not really helping the condition. Although we still express it, but still, like, it's not a function, technically. Now, let's talk about this, right? We do it because of that, and typically we use t as a parameter. That's what we call the thing, and we like typically, oops, what the heck? Yeah, sorry. So yeah, we use this in physics, like to define like a particle movement, like it might move like woo, like that. So we need to define it. All right. And now, typically, a lot of times, as t goes to infinity, we really are just tracing the same graph. We might be going like that, and then after some time, if t will start, or after t, at some point, x and y will start repeating. So it'll just retrace the graph again and again. So yeah, we get the idea of this. And now let's talk about some examples really fast. So I'd like you to graph the equation x equals 3t minus 2, y equals 2t plus 1. Alright. Let's make a chart. Good old, right? We'll talk about how to do it a faster way. But for now, good old chart. say t was 0. Say it was 1, 2, 3, 4. Let's see what happens. We'll get -2, 1, and then 4, and then 7, and then 10. Now what happens with y? We get 1 and 3, then 5, 7, and then 9. So now let's graph it. So now we only look at this now as a graph. We get -2, or actually I can use this thing behind me, right? This was the origin, right? So now our points would be -2, 1, 1, 3. Oh, you notice that it starts here. So now our graph would go from there to there. But let's first draw it. So now it's like connected dots, right? So now or whatever that thing is. 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Alright. 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 and then 10. It's just 3 more. And then 2 more. Alright, cool. Now you might notice that you keep going 3, 2, 3, 2, 3, 2, 3, 2. So it has a slope of 2/3, has a slope of rise over run, which is 2/3, right? We get that. Based on our intuition, it would be a line. It probably wouldn't be something like that. So yeah, and why is that? Well, we can actually look at this thing, right? As -2, so as this goes up in 3, this goes up in 2. Why? Because of this, we see 3 and 2. So, now, how could we have graphed that faster? Well, this kind of leads us, because we're used to our good old y equals f of x rather than this kind of weird parameterization kind of stuff, we can convert it. And let's see how to do that. So there are many ways to do it. The best ways for these simple things, what we're gonna do. Where is it? Oh yeah, it's just right here. Sorry, yeah. The best thing that we can do is we can do substitution. That's what most people do. So yeah, let's say so now we say that if we solve for t in x in this x equation, we get t equals x plus 2 over 3, right? We can substitute that into this equation. So now we have y in terms of x. Now we have y equals 2 times x plus 2 over 3 plus 1. That's equal to 2x plus 4 over 3. That's 2x plus 1, which is 2x plus 7 over 3. And that's our equation. 2/3 x plus 7/3. So this, if we had our y-axis, that would be 7/3. And our slope is 2/3, right? So that's how we got that. Another method, other than substitution, is elimination. Elimination isn't really the best for this, but it is helpful later on in more complicated ones. So we can multiply by 2, multiply by 3, like our typical method of elimination. 6t minus 4, this is equal to 6t plus 3. We substitute, we get 2x minus 3y equals -7. And that's the same thing. If you can convert it if you want, but it's the same thing. Cool. Now, we can also use more complicated ones later on, but for now, we're all good. Now, let's do some more complicated ones. Oh yeah, how do we convert from, yeah, we'll talk about that later. We'll talk about converting vice versa later, because that's a little more weird. There are infinite ways to do it. We can always do the simplest one, but still. Alright, let's graph x equals sine of theta. Now I see why we talked about trig first. Trig, remember that? That was a while ago. 3 minus 2 cosine of 2 theta. Ooh, scary, isn't it? Well, yeah, okay, let's do this. So, cosine, wait, what are we gonna do? Confused. Okay, so, let's use our trig identities, right? This is equal to 3 minus 2 times 1 minus sine squared, 1 minus 2 times sine squared of theta. Now that, how can we do that? Let's say that 2 sine squared of theta, oh wait, yeah, sorry, no, 2 sine squared of theta, we put it in terms of x, right? So now, and that is, so sine squared of theta is x squared. So now we have 1 minus 2x squared, and now that's equal to 3 minus 2 plus 4x squared, which is equal to 4x squared plus 1. Yay! So isn't it just a graph of 4x squared plus 1? Right, isn't it like that kind of? Well, you think. It doesn't go into infinity. Why is that? Well, let's see. We'll talk. So, if you think about it, the range, so the domain, wait, yeah, so the domain of f of x, wait, what am I saying? The range, sorry, yeah, so the range of the range of x, so the range of x, that's equal to the domain of f of x. Now I see why we study algebra 2, huh? The domain of this graph, alright? And now the range of y, this y thing, is equal to the range of this thing, right? Now, you might be wondering, why is that? Well, the y coordinate is all possible y, so the range is all possible y values, and so that's defined by this. That's why. And then all things that come out of the x will be the domain, right? So by definition, that makes sense. So all possible values of this is a domain of the graph, right? And all possible values of this is a range of the graph. Since all possible values of this is a range, and all the possible values of this is a range, I hope you understand it. If you don't, please tell us down below. I'll explain it in a better way. It's hard to explain, you know. So yeah, what comes out of this first equation will be what comes into the this graph, and what comes out of the second equation will be what comes out of this graph in terms of x and y, right? Since we're still graphing x comma y. So yeah, that was really weird. So yeah, now since the range of this first function is -1 to 1, we're only going to be counting -1 and 1. And since the range of this second one, since cosine of 2 theta ranges from -1 to 1, then 3 minus 2 times anything between -1 to 1. And that means that we'd have it ranging from 5 to 1, but that's backwards, sorry. 1 to 5, right? Because 3, because -2 times -1 is 3, or 2, and then 3 plus 2 is 5, and then we do the same thing with 1 and get 1. -2 times 1 is -2, and 3 minus 2 is 1. So now, yeah, that is our range. So 1, 5. 1, 5, wherever that is, right? Let's make a more accurate graph, right? Say this was the origin. We'd have this as our first point, right? And then 4x squared. So if you plug in, if you plug in 1, you get 4, 5, 3, 4, 5. And then if you plug in 2, you get 17, which is up here somewhere. And then here you get that. So our graph looks something like this, right? But since we're only limited to -1 and 1 as our domain, we get cut off right there. Since we have square brackets, we're including this. Alright, and then the range will be cut off at 1 to 5. So we are cut off here, right at that point, up to 5, and this, wait, where's 5? Okay, this is 5, so that's good. Lucky us, the graph will be black. We're including these points, remember that. Alright, so that's how you graph that. And yeah. So yeah, I'll talk about this more in another video. We'll do part 2 soon. So yeah, we know some good stuff so far. See you guys next time. Bye.